Hello guys, today we discuss about 3-bit asynchronous or ripple counter. Here the counter counts in up direction. Now 3-bit asynchronous ripple counter, so number of flip-flops required to design this counter is 3, and the counter counts 2 to the power n minus 1 state. So 2 to the power 3 minus 1, that is 7. So it will count 0 to 7. Here we have chosen JK flip-flop. So 3 flip-flops are here. All flip-flops inputs J and K are 1. Here we providing all the inputs of all the flip-flops are 1. Now first flip-flop, that is the least significant bit of the counter, we provide the clock pulse to this flip-flop. And for the remaining flip-flops, the output of the first flip-flop will provide the clock of the second flip-flop, and output of the second flip-flop will provide the clock of the third flip-flop. And now we draw the truth table as well as waveform. States QC, QB and QA. We have chosen negative edge trigger clock pulse, so we count all the time at the falling edge of the clock pulse. We assume initially output of all the flip-flops are 0. So QA, QB and QC are 0. Now state 0, all the flip-flops output is 0. Now when we apply the clock pulse to the first flip-flop, that is the least significant bit stage of the counter, then the input J and K of this flip-flop is 1. So whenever JK flip-flop, J and K inputs are 1 and clock pulse is applied, then the output, that is QN, is toggle. So here QA is toggle. Here it is 0, now it is 1. So QA becomes 1. Now the QA will provide the clock pulse of the second flip-flop, but it is 1, so second flip-flop does not activate it. Similarly, third flip-flop does not activate it. So second and third flip-flop will remain unchanged. This is one state. Now the second state, when clock pulse, once clock pulse is applied, then once again it is toggle. So QA is 0. Now QA provide the clock pulse of the second flip-flop. So second flip-flop activated, and input of this second flip-flops are 1. So output of the flip-flop toggles. So it was 0, now it is 1. And when QB is 1, so third flip-flop remain unchanged. So they are remain same, and now it is changed to 0 it is changed to 1 and it is remain same. Now for the next clock pulse, that is state 3, when we apply the clock pulse, then first flip-flop output toggles, so it was 0, now it is 1. When it is 1, then second flip-flop remain in the same stage, as well as third flip-flop remain in the same stage. So it is now 1, it is remain same, it is remain same. Now fourth state, once again we have applied the clock pulse. Now it toggles, so it was 1, now it becomes 0. So when it becomes 0, then second flip-flop activated and the output of the second flip-flop toggles. When second flip-flop output is 0, then third flip-flop is activated as QB provides the clock pulse of the third flip-flop. So the output of the third flip-flop toggles. So it was 0, now it is 1. So here it is 0, here it is 0, and now it is 1. State 5. Once again applying the clock pulse of the first flip-flop, so it toggles to 1. When it is 1, then second flip-flop remain same, third flip-flop also remain same. So then the sixth state, when we apply the clock pulse, then it changes the output, that is toggles 0. So second flip-flop activated and it toggles 1, and third flip-flop is remain in the same state. And the seventh state, once again applying the clock pulse, so it is toggles 1. When it is 1, then second flip-flop remain same state, that is 1, and third flip-flop also remain same state, that is 1. So you may write here initially it was 0 0 0, now it is 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0, and it is remain in the same state 1 1 1. So if we look the table, then it is up counting 0. Initially it was 0 0 0 state, then 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 and 1 1 1. So these 7 states clearly shown that the counter counts in up direction, and this is a 3-bit asynchronous ripple counter. Thank you for watching.